everybody, Cosmic Ray here. I thought I'd review with you what's going on. Chemistry, we found all these different shapes for the types of elements, the atoms. Each one has a different number of bonds, so we gave it a different shape. We've been drawing molecules. We're going to finish those up today. Twos, group 2, 2 bonds. Group 3, 3, 120 degree. That's called an isosceles triangle. Carbon is a diamond. Nitrogen is a right angle. Oxygen has 2 bonds, but as we'll see, groups underneath can have the electron pairs open up. So sulfur is a 6-sided star, phosphorus a 5-sided star. The halogens can do different numbers of bonds off a square. So we're going to draw some molecules here. This is the last, as long as this sign holds up, we're going to keep doing it. Sea Star passed away June 6th in Santa Maria due to all the neglect from the courts, and the animal control can bite me. They killed her. She frickin' needed some kidney foxtail help and $500 a transfusion. She still passed away horribly in pain. So in honor of Sea Star, this is her memorial, and this sign is held up since June 6th. So here we go. So what we're going to start with, North Atlantic seaweed, okay? The main chemical is this thing all loose. This next. We've got all kinds of shadows on here. Look how that works, huh? Fucatol, just like glucose. So for the diamonds, 1, 2, 3, 4, 5, 6 carbons in this thing. So we just draw 6 diamonds across. Can number them. So 1, 2, 3, 4, 5, 6. Now when we look on the end, we see this is a methane, so there's 3 hydrogen dots. Now we got some alcohols. We color code everything, so green up here with the alcohol. Big O, because O's bigger, right? So we got the color coordination, we got the size comparison, and then what we do for any oxygen with a proton in it, we put it on the inside here. So that's our representation for an alcohol. So just like the carbohydrates, this kind of essentially is a sugar. So look at it this way, as a big O. Over here on top, a big O. So you can make these diamonds to be up and down. You can do them however you want. We're just keeping this real simple here. Put the protons in. Close up. Now there's no double bonds in this, so even though it mimics vitamin C, it's more of a glucose, so it's not going to have an anti-free radical character to it. Now look, see, we missed one. So when we look here again, so we can see we got the total number correct. C6O6H12 is glucose. Well, we got our 6 carbons. Just like glucose. Of course, there's only 5 OHs, so we're 1 OH short. So call this like glucose minus an OH. So now we come through and we do our H's on here. Well, 4 bonds for carbon. Only leaves 1 more for these. So again, you can draw these real neat, make them look all fancy and that, but I want it so you can draw it on a napkin in the restaurant or the chow hall, whatever they call it in school there. So we can use markers to color it up better. So here's our green. Oh, this is the green, it doesn't work good. So the other thing what we use is crayons. Kind of messes up my red. This is all recycled paper, and this is carbon copy stuff that I shouldn't be using. Next, what we do is we color coordinate the carbons so that a methyl, carbon with 3 H's on it, we've been coloring those purple. Carbons with 1 H have been getting brown. So then when you look through, you can correct the number of bonds that are on a carbon, because you'll see by the side group if something's missing. So again, these crayons are recycled. God bless the church that throws away all their stuff. 1 H here. This really is a useful tool in higher organic chemistry because you really got to know the characteristic of the carbons. And our color coordination is really neat. Benzene, for example, when you got 1 H on the aromatic ring, brown and blacks are the carbons. So 2 here. 2s we've been given kind of a burgundy color to here. So kids, you can pronounce this however you like. I'm going to have to, for the airwaves and the FCC, pronounce it as fucatol. This is in your North Atlantic seaweed. Who said chemistry can't be fun? What are you doing there, Mary? Oh, fucatol. I'm studying chemistry. Okay, diphenhydramine. This is better known for blocking your histamine receptors, Benadryl. So for you advanced students, we're not going to do the Schroeder carbon diamonds on these benzene rings. We're going to do it shorthand because it takes too long. But everywhere else, we're going to use the diamonds for carbon. So that's a carbon going to an oxygen. It's going to go over here. We're going to shortcut this to a benzene ring. So since we don't use this shape, the hexagon, for any of our elements, we're going to let it be the benzene ring, and wherever yellow is, this is where there's aromatic pi bonds on the electrons around it. So like I said, when you do the Schroeder diamonds on this, brown is what you end up with for the carbon. So we're going to make our circle here of aromatic circle brown. And we still got one. Is this the carbon paper where the markers don't work? It kind of works. So whenever you see the 1 H on these, you'll know that it's benzene. So see here. 1, 2, 3, 4, 5. 1 on that carbon. So that comes up now to an oxygen. Oxygen's bigger. And that oxygen goes to a carbon. So we're drawing this here. So 1, 2 carbons, and a nitrogen, and then it ends with a methyl. So 2 carbons on here. 1, 2. And we need a nitrogen right angles.